Alright, this video is going to cover some odd problems for Chapter 6, Section 3, that's Vectors in the Plane. This is for the Day 1 lesson, and these are the even problems that you'll see on WebAssign or from the textbook. So let's look at some or odd problems that are very similar, like if you're having trouble with 12, 11 is going to help. If you're having trouble with 16, 15 is going to help. And I've got an odd problem for all the evens in the homework. So number 11, the directions say, determine whether u and v are equivalent vectors. Explain. So they give us vector u, the initial point, and the terminal point. Vector v, its initial point and its terminal point. So to show that they are equivalent, we want to check their magnitudes and their direction. Magnitude is the same as the length. Direction is the same thing as slope. So let's do each vector one at a time. I'll use red ink here for vector u. We start at the initial point, and the vector goes and stops at the terminal point. All right, so let's see here. Magnitude of u. Remember, that's just going to be the distance formula. So we're going to subtract here negative 1 minus 2, and that'll be squared. And then a 4 minus 2, also squared. So in this set of parentheses, we're going to get a negative 3, square that and get a 9, plus 4 minus 2 is 2. Oop, that squared should be outside the parenthesis. 2 squared is 4. So that's going to be 13. The root of 13 is the magnitude of vector u, or that's its length. And now let's find the direction or the slope. Direction or slope. So we're just going to do y minus y over x minus x. So here y minus y will be a 4 minus 2 over top of negative 1 minus 2. So that'll be 2 in the numerator, 3 downstairs, and it's a negative. So negative 2/3 is the direction of vector u. So let's check out vector v and see if they are equivalent. Vector v, starting at the initial point and going to the terminal, the magnitude of this vector is. So let's do a negative 5 minus negative 3, and we're going to square that. And then 2 minus a negative 1, and square that. So negative 5 minus 3, that'll be, oh, did I mess something up there? No, negative 5 minus a negative 3, I'll turn to a plus. Negative 5 plus 3 is negative 2. That's going to be squared. 2 minus a negative, that'll turn into a plus, and that'll turn into a 3, also squared. So just like above here, negative 2 squared, that'll be a 4. 3 squared will be a 9. So that will also be a root 13. So their magnitudes are the same. Are they equivalent? Well, we've got to find the slope or the direction of this second angle or vector v. So that slope is y minus y, 2 minus negative 1 over x minus x, negative 5 minus negative 3. So up here, that'll be a 2. And, oops, excuse me, 2 plus 1 is 3. And then down here, add the opposite, that'll be a negative 2. So they're reciprocals, they're not the same. The magnitudes were equivalent or equal, but the directions were different, so these are not equivalent vectors. If you want to check out one where they are equivalent, number 13, they turn out to be the same. Number 15, find the component form and magnitude of vector v. Well, they didn't label it here, but our initial point is the origin 0, 0. So our component form, remember that's sort of like an ordered pair here. And we're going to go from terminal point minus initial point. So this will be a 1 minus 0, comma, 3 minus 0. That's a nice easy one. So 1 minus 0 is 1. 3 minus 0 is 3. So there's our component form. Now the magnitude, once we have it in component form, is real easy. To find the magnitude of this, you're just going to do a square root. 1 squared plus 3 squared. 1 plus 9 is 10. Root of 10 is the magnitude of vector v. Let's see here, 31 and 33. Vector operations, they want us to find for part A, u plus v. B, we're going to subtract them. Part C, 2u minus 3v. And then it says, ooh, sketch the resultant vector. We might not do that for all of them. Okay, first one. Part A, u plus v. So here's my u, here's my v. I'm just going to add the first component. 2 and 1 is 3. Add the second components. 1 and 3 is 4. There's my answer. For part B, we're just going to subtract them. Order is important here in subtraction. It's this, u minus v. So 2 minus 1 is 1. And then 1 minus 3 is negative 2. Now for part C, we want 2u. So I'm going to take this one and double it. I'm going to double the 2 and 1, 2, a 4, and a 2. Minus, I'm going to do it this way, minus, I'm going to do 3 times this. If I distribute a 3, that'll become a 3 comma 9. And now subtract. 4 minus 3 is 1. 2 minus 9, negative 7. Okay, some different vectors here. One of them is the 0 vector. So let's see how this impacts the problem. Part A, we just add the components. Negative 5 plus 0, comma 3 plus 0. So it's the same thing as vector u. U plus v is the same as u, and that makes sense because the v vector is the 0 vector. And now we subtract. Same order, u minus v. Negative 5 minus 0, negative 5. 3 minus 0, 3. Same answers for A and B. Part C. 2 times u, so we're going to double the numbers in here. Negative 10 comma 6. And then we're going to subtract 3 times these numbers. Well, 3 times 0, 0 is 0, 0. So we subtract here. Negative 10 minus nothing is negative 10. 6 minus 0 is 6. Let's see here, 37. The magnitude of 5u. Now remember, there's that little sort of shortcut on here, or at least it makes the simplification easier. This magnitude of 5u is the same thing as the absolute value of 5 times the magnitude of u. And since that 5 is already positive, we can drop the bars. So we can just figure out 5 times the magnitude of u. And u here was given in this component form. 5 times the magnitude of this, 2 comma 0. Remember, to find the magnitude of that, just give yourself a radical. Square the first number, 4, plus square the second number, 0 squared is 0. Oh, so this will work out perfect. 4 plus 0 is 4. And the square root of 4, that's going to turn into a 2. 5 times 2 is 10. Now here, negative 3 times vector v, and that is the magnitude, so we can use that sort of shortcut again. We can bring out that constant, the negative 3. Now the bars are required. We're going to drop the bars when we drop this negative, so this becomes 3 times the magnitude of v. All right, v is right here in its component form, so let's give ourselves a radical. The first term is negative 3, square that to a 9. The second term, 6, square that to a 36. If we add those up, we get 45. Now 45, we can reduce that. 45 is 9 times 5. So this square root of 9 is going to come out as another 3. Hit this 3 multiplied to a 9, 9 root 5. And that is our last odd problem. I hope the video helped.